to class. That's my dad.
What we're going to look at first is how to find the volume of a prism, in this case a rectangular prism. Now, normally when we're talking about prisms that are rectangles or boxes, we tend to fall back on the very basic plug it into the formula and go. We're going to try to avoid that today. Most of us classically know the volume of a box as the length times the width times the height. Plug all your numbers in, shake, out pops an answer. For our purposes, we're going to change that up a little bit and look at it as this. The area of the base times the height. Now the advantage of this particular formula is that this will apply to any kind of prism. It does not have to be rectangular because we're just going to find the area of that base, multiply it by the height. Now in the case of a rectangular prism, when we're looking at the base, it's a rectangle. That's that distance along there. So that would be my base, and then I can multiply that by the height. Now the math doesn't change. What we are looking at trying to modify, however, is how to avoid just using this one formula that only applies to rectangles. This will apply to cylinders, it will apply to triangular prisms, any stack of polygons. I can use that formula to get me the volume. Now we can plug everybody in. The area of the base is going to be 13 by 3. And I'm going to multiply that by the height. And then I can just run that through my calculator, and that's going to give me a final answer. So break out the calculator. There she is. Let's see, 13 times 3 gives me 39 times 5. Final answer, 195 cubic centimeters. Now the units are important because they remind me exactly what I'm looking at when it comes to how I got to this. I did 3 different linear measurements together to get me this answer with a third power on my unit. So that tends to help me troubleshoot any potential problems I may have. In this example, we're looking at the volume of a cube with 15 inches along one side. Now with cubes, you're only going to get one measurement, and you need to know how the cube works in order to see how that plans into our work. Now, a cube is a type of prism, which means we're going to apply the prism formula for volume to this. In this case, I look at my base. The base of a cube is a square, which means it's 15 inches by 15 inches. Now when it comes to finding the height, I apply the same principles. The height is also going to be 15 inches because a cube is made up of squares. A square has the same distance on every side. So when I go to plug into the formula, my base is going to be 15 by 15. The height will also be 15. Volume for a prism is the area of the base times the height. So that's my base, 15 by 15, times the height of 15. I can now go to my calculator, and I can crank that out. 15 by 15, so that's going to put me at 225 here, times 15 again for the height. (3,375 cubic inches). Area of the base, which was a square, 15 by 15, times the height. It really comes down to that formula. Now, again, the advantage here is this is also a problem we might be able to get classically. You will also see problems that look like this. Volume of a cube is equal to a side cubed. That is what we did. We took the side length of 15 and we cubed it to get our answer. Either method works. Our last example in this set is to find the volume of a triangular prism with a right triangle as its base. Now the right triangle is given as having legs of 5 and 7. The overall prism is given as having a height of 9, and all units are in yards. There are a couple of challenges we have to keep with this. The first challenge on our list is that in our volume formula, volume being the area of the base times the height, there's a height. Now our prism is a triangular prism, meaning it has a triangular base. The area of a triangle is 1/2 small b base times height. These h's are different heights. There are a lot of different numbers to keep track of here, and so you want to make sure that you're taking your time and you're showing diligence with where you write your values. It's an easy place for students to make mistakes. Reuse the number 9 as the height in the triangle base. And that's not something you want to let yourself fall into. So what I'm going to do is use a little color to emphasize here. That triangle represents the base of my prism. Now granted, it's on the front, but remember, prisms don't have to be standing upright structures. They can be laid out flat. I should be able to see a stack of triangles going back into the board here, making the triangle the base of the prism. So my first task will be to find the area of that triangle. In this case, that area is going to be 1/2. Since it's a right triangle, that means I can use the 2 legs in order to calculate its area. If I did not have that, I'd have to have some other measurement, such as that, to help me out. Some kind of altitude within the triangle to support me. In fact, many times you'll see this height referred to as the altitude of the triangle, as opposed to the height of the triangle. Part of that reason that we were so pointed at back when we covered that was to avoid confusion now. So 1/2, I'm going to use this as the base, and this is the altitude of the triangle. I can flip them around since there's a right angle there. 5 by 7. That would give me the area of the triangle base. Times the height of 9 gives me the volume of the overall triangular prism. So here's the triangle base. Here's the height of the prism. This is the area of that triangle on the front. This is how tall or how long my stack of those triangles works out to be. Now I go to my calculator. So 5 by 7 times 0.5. This gives me 17.5, if you're the kind that likes to write things down by steps. Multiply that by 9, I get a final answer of 157.5, in this case, cubic yards. That would be my final answer for the volume.